app. And next I'm going to call up Mark Peters from the Enterprise Strategy Group to introduce the next speaker. So Mark, will you please take putting the clicker here.
Thank you. I think I've got one. Good morning. Come on, it's Thursday. Good morning. I have just a, thank you. It's my dad. So I have just a couple of minutes to introduce the next keynote speaker, which is Shahar Feinblit from Kaminario. It's funny, if you think our previous speaker, you heard vowels from Transylvania. So it's Transylvania, but my previous introducer only had to say vowel. I have to say Shahar, and I've been trying really hard, so I hope he's not squirming in the back to get his name correct. Anyhow, Shahar is the CTO at Kaminario. Kaminario, if you're not familiar with them, are one of the all-flash array vendors currently making waves in the industry. They are still VC funded, pretty heavily VC funded, which is a good thing. It means they've been able to raise the money that they need. And very fully functioned systems that they produce. I mention this because in his previous role before he was CTO, Shahar was the VP of Product Engineering in charge of producing K2, which is their main platform. As I say, he's now the CTO, so as well as R&D, that puts him in charge of strategy. And what I liked when I was reading his information is that he talks about not just being in charge of technical aspects, but the team aspects, because we all understand that this industry takes a lot more than just understanding the technology. It requires the manipulation, optimization, motivation of many people to make things happen, and that's something that we sometimes forget. He's currently based out of Israel, was educated, got his BSc in computer science at Haifa, and as many people who do that in Haifa, went to IBM in Haifa and worked considerably on DS8K and SVC, so both a hardware and a software background. And you may feel sorry for him. He's moving, well, not feel sorry about the fact he's moving to America, that's no bad thing, but he's doing it next Thursday. So sometime between talking to you, he's nipping back home, picking up a wife and family, and coming back here next Thursday, which is suitably mad. So, before he does his move, he's going to talk to you. The topic is how all-flash arrays need scalable, cost-efficient, software-defined architectures. So putting another word around that, that's about scalable and cost-efficient software. And those aren't words that we always put together. So I'm interested to hear what he has to say. I hope you find it good as well. So with that, would you please welcome Shahar Feinblit on stage. Did I nearly say it right?
Yes.
Nearly, okay.
Okay, it is great to be here today. Unfortunately, last year I missed the Flash Memory Summit when we won the Flash Technology Award. And this is why I'm super excited to be here today in the Flash Memory Summit. Let me ask you a question. When you want to drive really fast, which car will you use? Will you use a minivan? Or maybe you will use a Ferrari? What will you choose? Of course, each one of you will use a Ferrari. But for the cost of a minivan, this is what at least I will want to do. And this is all the story of what I will explain today, how to make things more affordable. So Flash is fast. We are in the Flash Memory Summit. Maybe Flash is the slowest technology here in the Flash Memory Summit, but we all need to remember the basics, that Flash deliver the performance that a customer, an enterprise customer are asking. It is solving the performance issue of the data center. And the value of Flash is much beyond performance. There are many other values of Flash. On the operational side, things are much simpler with Flash. You do not need to tune the system. Provisioning storage is between 5 to 10x faster than traditional system. And of course, the data center costs decline dramatically with Flash. Also on the business side, Flash brings many, many advantages so customer can do more, can make a better business decisions, and meet the compliance and SLA. And I want to say one more thing about performance. High performance is important. What is more important, and it's a real value of Flash, is performance consistency. Because this is the real value that Flash brings. So the question is, if it's so fast, so many advantages, why do we still have HDDs in the world? And this is a question that Tunisia group were asking customers from all over the world in 2013 and in 2015. And they were asking again, what is limiting you from moving more aggressively to Flash? And the answer was budget. So in 2013, 77% of them said that it's a budget constraint. In 2015, it declined to 58%. Now, it's a good progression, but this is still the main challenge of any all-flash array. How to bring this great benefit in the most cost-efficient way. And there is good part here. The good thing is that Samsung, Micron are developing great technologies that if you are using it right, you can bring the cost down significantly and make it the most cost-efficient technology for the data center. And so what we see that SSD capacity and cost improve much faster than Moore's law. And how is it happening? It happens with two main technology, 3D NAND and TLC. Now, you all heard the presentation from Samsung. I think it was on Tuesday, that they will be able to build a 16 terabyte SSD next year. 16 terabyte SSD means that SSD density is better than HDD densities. The days that SSD density are better are over. And if we look at the progression in technology, Flash is making much faster progress than DRAM, than HDDs, and much faster than Intel CPUs. So any architecture should be ready for these HDDs. And yes, there is one caveat, and this is the endurance. The endurance of these SSDs is not as good as the previous generation. So this is the main challenge of an all-flash array architecture. And this is the main challenge for the data center, how to utilize these SSDs, considering the challenges, how to deploy such large SSDs, and to take care of the endurance. So let's tackle each one of them. So first, I would like to tackle the density. So let's discuss architectures. So there are two main architectures. I think in every lecture about system, people mention it. So I'm sure you know it before you arrive to the conference, but so there are scale-up architecture and scale-out architecture. A scale-up architecture, you basically have two nodes and a storage attached to it. So performance cannot scale beyond the performance of the two nodes, and capacity can scale until some certain limit. These systems tend to be cost efficient because you are paying more for the flash and less for overhead, for CPU, for networking, and for other components, but it is not scalable. On the other end, there are scale-out architecture that are optimized for scale, optimized for performance. If you have good scale-out system, the performance and capacity scale linearly, which is perfect for performance. It is perfect if you want to break the benchmark. But the problem of this system is that they tend to be very expensive compared to a scale-up architecture. So you have one approach with a great benefit of performance, one approach with a great benefit of cost, and you have a customer. And when you are a customer, you have two basic requirements. I need X amount of terabyte, and these are my capacity, performance requirements. Of course, you have many other requirements, but these are the basic two requirements of any enterprise customer in this room and in other places. And if we look at the scale-up system, for this specific customer, one system is not able to meet its requirements. And what does it mean? That you need to over-provisioning capacity, you need to manage multiple systems, it means complexity and lack of efficiency. On the other end, a scale-out architecture, yes, a scale-out architecture can meet any performance and capacity needs. But in this specific case, it is done by over-provisioning performance. Let me give you an example. Over-provisioning performance is like going to Apple Store, sorry Samsung, and asking them for a new cell phone for a 7-year-old kid. So you need capacity for the games, and you need capacity for the videos. They are using it with WhatsApp too much. But you don't need a really, really fast cell phone. So imagine that they will tell you that you can only buy iPhone 6, because this is what they can give you if you want 64 gigabytes of memory. It doesn't make sense. It doesn't make sense as well on enterprise system. So over-provisioning performance is expensive, and you want to meet the customer requirement in the most optimized way. And the way to do it is to build a system that can scale up and scale out. So we can meet customer requirement in the most cost-efficient way. So, and customer cannot predict what will be the requirement in 1 year, 2 years, because the business is changing. They really do not know. So, so you give them exactly what they want, the performance and according to their performance and capacity requirement. And later on, if they need more capacity, they will only buy capacity by scaling up. If they need more performance, they will only buy an additional server and scaling out with capacity, and they will scale to the new needs of the customer. Now, I was covering the first challenge, which is scale. And I explained why you need to scale up and scale out, and why you must be able to utilize these high-density SSDs. Today it's 2 and 4 terabytes. Tomorrow it will be 16 terabytes. The other challenge is endurance. So like, we do not want to over-provision in capacity and over-provision performance. You really do not want to over-provision endurance. Because when you over-provision endurance, it is expensive. And you want an all-flash data center. You want a general purpose storage, all-flash, which is optimized for your customer. You want it to be more economic than any hybrid system. And modern software-defined all-flash array architecture improves SSD endurance by 4 to 8x, which is a magic. How is it done? It is done by many innovative ways. Of course, by data reduction, deduplication, compression, and of course, data reduction must be inline. Otherwise, you are writing twice. So you're saving the space, but you are not saving the endurance. So you need to have the data reduction inline in order to save both space and endurance. In addition, the workload should be balanced across all SSDs, so you do not have an hotspot, because otherwise the worst case might be huge, and you need a drive with hundreds of writes per day, which doesn't make sense. And of course, the way of writing to the SSDs, the way the RAID is implemented, to be optimized for low write amplification. So all these things together are improving the flash endurance much beyond the specification of the SSD. The specification of the SSD are for just random write. Now, the good thing also is that we have great statistics from customers. We have many customers, so we have great statistics from the customers. And we were asking ourselves, what should be the target endurance for customers? Because you do not want to overspend, but on the other end, you do not want to get into a situation that you do not have, that you are out of RAID cycles. So what we see is that 97% of our customers write the entire data less than 1 write per day. And after all the optimization that I mentioned in the previous slide, it translates to 0.15 writes per day. Now, there are SSDs with 1 write per day, or even half write per day, 5 writes per day, and even 15 writes per day. Now, with 0.15 write per day, even an SSD with 1 write per day can sustain more than 30 years of endurance. So there is no point of buying an SSD with 10 write per day. It's just waste of money. But you need the right architecture with all the optimization to improve the flash endurance, because otherwise, if you may have hotspot, yes, you need even a drive with 15 write per day will not be enough. But if you are optimized, yes, it is possible. Now, flash is also changing many other things. And the first thing that I think a very critical element is the way of buying storage. In the past, there was a cycle of every 3-4 years of replacing the old storage. So it was working like this. It was crazy. You were buying a new storage. So the first year was to migrate the data from the old storage to the new storage. In some cases, it took only a few months. Now, you can enjoy the system for 2 years, and now you have a new project because it's a forklift upgrade. You need to migrate from the new, which is now old, to a new a box, and customer think it's ridiculous. And I was amazed when I realized that this is what customer is doing. And with this type of architecture, you can really change the way storage is acquired. So customers will buy exactly what they need at the day of the purchase, and for there, they can scale up or scale out. But we see that there is a great advantage in technology, so you don't want to scale up or out with old technology. Last year, we were using MLC. Now we are using 3D NAND. We want to scale the same cluster with 3D NAND, which is much more cost efficient. So by doing this, you scale the system in the most cost efficient way. And you still preserve the old investment because you do not want to replace the old investment after a year, 2 years. You want to preserve the old investment for at least 5 years because otherwise it's too expensive. And of course, when times come, you need to decommission the old hardware, but only when times come. You don't want to decommission for the wrong reason. If you can still use it and it's effective, you should continue to use it. And everything is done while the cluster is always online, adding new stuff, adding new technologies, decommissioning all technologies. Everything should be done when the system is online. It's online forever. It is a huge change in the way storage is consumed in the data center. Now, so what we are doing in Kaminario. So first, I think it's the best way to explain the mission. We took the mission to enable our customer to scale their business easily and cost efficiently. So there are 3 pillars here: scale, easy, and cost efficiency. And what we realize is that there isn't one vendor that can do all 3. Some of them are very cost efficient. It's the scale-up architectures. Others are very scalable, but expensive, a typical scale-out architecture. And we took the mission to be both scalable and cost-efficient because we think that all-flash should be the general-purpose storage for any data. So what is unique about Kaminario? So I will go through a few of the points. So flexibility, we're able to scale up and scale out. Easy. Easy means performance consistency. Easy means that you don't need to do tuning anymore and that everything is online. Cost efficiency, we are more cost efficient than hybrid array. And in the next few years, you will hear from the press few things that will take it even further. And of course, we are dealing with enterprise customer. Enterprise customer means enterprise quality, enterprise functionality with all the enterprise feature. And now I want to summarize. So I would like to look at the evolution of all flash arrays. So we started like 4 or 5 years ago with storage arrays that were very, very, very expensive. And they were using SLC media, and it was to solve specific application, specific problem. Then there was a transition to more software-defined architectures. These architectures were less expensive, and flash became affordable for more use cases, which is great. But it is still not the situation that you can put everything on flash. You cannot put all the active data on flash, which means complexity, because you need to move data to the flash system, out of the flash system. So it's extra complexity. So you get tons of value for flash, but you get some complexity. And now there is a new transition. A new transition comes also with new technologies, 3D, 3D MLC or TLC. This system can scale up and scale out. They are software-defined architectures, and they are general-purpose systems. And this is the transition that is happening today. And customers are starting to use all-flash for any active data. And it's not that it's just more cost-efficient than hybrid array. It's also simplified their work because they do not need to do all the tiering, all the migration. And this is why it is winning. And we are in Kaminario are making all-flash array data center a reality. And thank you very much. If you have questions, we'll be glad to take.
Thank you, sir. Sachar is going to be here for a few minutes to questions. I think before we even do that, do you want to talk about there's a giveaway of some sort? Giveaways are always good.
Okay.
Let's pick the winner.
What's it for?
It's a GoPro and an auto-follow drone.
Did everyone hear that? It's a GoPro and other stuff. Oh, a drone.
Yes.
Am I in the competition?
No.
Oh.
Spartan Mansoor is the winner. If you could just meet us in the back, we'll talk to you about it. Thank you.
Thank you very much.
I can't see a whole host of you leaping up for questions. I'm sure you all need lunch. So with that, we'll wrap this. Enjoy lunch, and the next session is back in here at 2 o'clock. Thank you.